Hi folks, are you fresh to coding? Or are you switching over from other languages like Python, JavaScript, or even C++ and thinking, should I start learning Java in 2025? Then you are at the right place. Because in this video, I'm giving you the ultimate Java roadmap for 2025. Packed with everything you need to go from beginner to advanced. That is understanding from, what is a JVM? To, hey, I just built a Spring Boot microservice. We're talking only about the must-know skills for becoming a real-deal Java developer. But before we dive into the roadmap, let's settle the big question. Is Java even in demand in 2025? Yes, it is. From powering back-end systems at Netflix, Amazon, and Google, etc. Java is everywhere. It's not just surviving, it's thriving in enterprise, cloud, Android, and even AI integrations. So if you're thinking you might be late to the Java party, nope, you're right on time. Companies are always looking for good Java developers. There's a massive ecosystem, that is tools, frameworks, and communities to learn from. And when it comes to career growth, Java gives you solid, long-term opportunities. So let's go, grab your cup of tea, and let's dive in. Welcome to the Java Roadmap 2025. Alright, before we get into the actual roadmap part, let's talk about tools or prerequisites to start with. Because every developer needs their trusty sidekick, and in the Java world, that means choosing the right IDE, or your integrated development environment. You've got a couple of solid options out there. There's Eclipse, old school, reliable, open source. And then there's IntelliJ IDEA, modern, sleek, and honestly, kind of a developer's dream. Now, both get the job done. But if you ask me, or 90% of experienced Java devs, IntelliJ is the way to go. Alright, IDE? Done. Now let's talk about the heart of your Java setup, the JDK, or Java Development Kit. This is what actually lets you compile and run your Java code. Now here's the deal. There are a bunch of Java versions out there, like 8, 11, 17, and the latest LTS, that's long-term support, version as of 2025 is Java 21. While Java 8 is still used in some legacy systems, it's kinda ancient at this point. So for learning and building modern apps, I highly recommend you go with Java 17 or Java 21. Both are stable, well-supported, and come with tons of performance improvements and cool features. So download the JDK either version 17 or 21. Install it, and make sure your IDE points to it. Now you're fully armed to start your Java journey. Alright, so now that you've got your IDE and JDK ready, it's time to start your actual Java journey. We begin with the basics of Java, also called core Java. Think of this as learning how to walk before you run. First, you'll learn things like syntax, how Java code is written. Then, data types, like numbers, text, true, false. Then, variables, containers to store data. Then, operators, to do things like add numbers or compare values. Once you're comfortable with writing basic code, we move on to how your code makes decisions using control flow. This includes if-else, switch, and loops like for, while, and do-while. Basically, you're teaching your program how to respond to different situations and repeat tasks. Then comes one of the most important topics, object-oriented programming, or OOP. This is how real-world Java applications are written. You'll learn classes and objects, the building blocks of Java programs. Inheritance, to reuse code from one class in another. Polymorphism, to write flexible code that works in many situations. Abstraction, to hide complex details and show only what's needed. Encapsulation, to protect and organize your code properly. Next, you'll learn exception handling. This helps your program deal with errors without crashing. So if something goes wrong, like a file is missing or a user enters bad data, your program knows how to handle it smoothly. After that, we explore the collections framework. This is how you store and manage groups of data. I will not say you need to learn all the collection data structures. You should learn about at least list, set, map, which are most commonly used. And finally, we step into the cool and modern features from Java 8. These help you write cleaner and shorter code. Lambda expressions. Write functions in a simpler way. Streams. Work with data more efficiently. Optional. Handle values that might be missing, without crashing. Master all of these, and guess what? You'll have built a strong foundation in Java, ready to move into advanced topics like databases, web development, and Spring Boot. Alright, so you've got the basics down. Now it's time to level up and enter the world of advanced Java. This is where your skills go from just coding to building real-world, high-performance applications. Let's break it down. Ever wished your program could multitask like you do? Listen to music, download files, and chat, all at once? Well, that's exactly what multi-threading is. You'll learn how to run multiple tasks at the same time, making your programs faster, efficient, and more responsive. Next, JVM internals. It's time to go under the hood. JVM stands for Java Virtual Machine. It's what runs your code. You'll learn how memory is managed, how garbage collection cleans up unused data, and how classes are loaded in the background. It's like learning how the engine works in your car, super helpful for writing optimized, high-performance code. Next is reflection. Sounds fancy, right? Reflection in Java lets your program look at itself while running, like inspecting its own structure and making decisions. It's useful for building flexible tools, like frameworks or libraries, where your code needs to adapt to different situations without knowing everything up front. Next is the file handling part. It's done with I/O packages in Java. When your app probably needs to read or write data, like saving user info, reading a config file, or logging errors. That's where Java's file I/O comes in. You'll need to learn how to read from and write to files, and handle them like a pro. Now let's talk about something every Java developer needs: build tools and project structure. Because trust me, once your project grows beyond a single file, keeping everything organized and working becomes a whole new challenge. First up, Maven and Gradle. These are build tools. They help you manage your project, compile your code, run tests, and even package it all up for deployment. Think of Maven and Gradle as the smart assistants that automate all the boring stuff for you. They also help you manage your dependencies, that is, the external libraries your project needs. Which brings us to the next point. In Maven, you'll use a file called pom.xml. In Gradle, it's the build, Gradle. These files list out everything your project depends on, like a recipe for building your app. Just write the library name, and bam, it gets downloaded and added automatically. And while we're here, let's not forget project structure best practices. It's super important to organize your code properly. Folders for source files, test files, resources, configs, and more. Why? Because clean structure equals less confusion plus happy developers, including future you. Mastering Maven or Gradle and following solid project structure makes your life easier and your code cleaner, especially when working on big teams or deploying real-world applications. Now that you've got a strong Java foundation, it's time to step into the real world of Java development with Spring Boot. What is Spring Boot? Spring Boot is like Java on steroids. It helps you build production-ready web apps and APIs super fast, without all the boring setup. It's one of the most in-demand skills in the Java world right now. Building REST APIs with Spring Boot, you'll learn how to create RESTful APIs, which basically means you're building endpoints that can send and receive data over the internet. This is how apps talk to each other, whether it's your front-end app asking for user data, or a mobile app saving a form. Next comes the security while building data exchange platforms. Securing your app with Spring Security now. Imagine you built a cool app, but anyone can access it, change data, or mess around. Yikes. That's where Spring Security comes in. It helps you lock things down, like requiring users to log in, restricting access to certain pages, or protecting sensitive data. Mastering Spring Boot plus Spring Security means you can now build robust, scalable, and secure backend applications, like the ones used by real companies, in real production environments. So, you're building a Java application and you want to talk to a database. But how do you actually do that? Well, there are a few ways: JDBC, Hibernate, and Spring Data JPA. Let's break it down super simple. First, there's JDBC, Java Database Connectivity. Think of it like writing raw SQL and manually connecting to the database. You write queries, open connections, handle exceptions, all by yourself. It's like driving a stick-shift car. Full control, but a lot of effort. Now, meet the smarter approach, JPA with Hibernate. JPA is the standard that defines how Java objects should be stored in a database. And Hibernate is the tool that actually does it. Together, they let you skip writing SQL for most things and just work with simple Java classes. With JPA and Hibernate, you write plain Java classes and add some easy annotations. That's it. Hibernate takes care of saving, updating, and deleting your data, all without writing a single line of SQL. So, to sum it up, JDBC is low-level and manual. JPA is even easier with less code and more power. Choose what fits your project and your comfort level. Building code is fun, but making sure it actually works? That's where testing comes in. Today, let's walk through some of the most popular testing tools in Java: JUnit, Rest Assured, Cucumber, Karate, and Postman. First up, JUnit. It's the go-to tool for unit testing your Java code. You write small test methods to check if individual pieces of your application work. Test a function, check a calculation, or validate logic, fast and easy. Next is Rest Assured, perfect for testing REST APIs directly in Java. You send HTTP requests like GET, POST, PUT, and DELETE, and check if the responses are what you expect. It's like Postman, but inside your Java code. Next is Cucumber. Have you ever wanted your tests to read like plain English? That's what Cucumber does. You write your tests as easy-to-read stories, called Gherkin, like, given, when, then, steps. Cucumber bridges the gap between developers, testers, and even business teams. Now, meet Karate, the all-in-one testing framework. It's built on top of Cucumber, but it's designed specifically for API testing. The best part? You can test APIs, UI, and even performance, all with easy scripts and no heavy coding. And of course, Postman, the most popular tool for manual API testing. You can quickly send API requests, inspect responses, and even automate collections of tests. Postman is super handy for exploring and understanding APIs before you automate them. So finally, it's good to understand testing is the safety net that lets you build amazing applications with confidence. Keep testing, keep building, and keep growing. And that wraps up our Java roadmap, a clear and simple path to help you get started and grow with confidence. We didn't dive deep into every topic today, this was all about giving you direction. But don't worry, we'll be covering each topic in detail in upcoming videos. So if you're serious about learning Java the right way, step by step, in plain English, hit that like button, drop a comment if you have questions or topics you'd like me to cover. And don't forget to subscribe so you don't miss the deep dives coming your way. Thanks for watching, and all the best on your Java journey.